Hey, folks. Good morning, good afternoon, good evening, and thank you for joining our 15th episode on the DocumentDB Insider Hour. Super happy to be here. Happy New Year to everyone. As usual, I have my amazing co host, Cody Allen, with me. Let me bring him on here. Hey, Cody.
Hey, what's up, everybody? Happy New Year. Merry Christmas. Happy holidays. Hope everybody enjoyed their long break off. I know I did.
Yeah, it was a much needed break. Thanks for being here, Cody. How are you this morning?
Doing good. So I have to ask you, what fun things, like what's the most fun thing or most notable thing that happened to you over the Christmas break?
There's one thing that I would like to call out. I started learning pickleball.
Pickleball. Oh, man. So they built, of all things, they built some pickleball courts in our neighborhood. I had no idea what it was, like no idea. But of course, they build them. The kids want to play. So we go all in. Like we go get the rackets and the bags and whatnot. Um, we're a pickleball family, man. Like we might need to hook up and get some competition going.
Let's do that. Good to know. I
That's
enjoy it.
cool.
I'm continuing to learn the game. So yeah, that was one new thing I learned, and one of my New Year resolution to get better at it.
Heck
So
yeah, I like it. You know what surprised me about it is the fields are so small, you think that it's not going to be that physically demanding. Oh my lord. You sweat, dude. You
twice,
sweat.
twice singles there. You
Yeah, exactly. That's
yeah,
cool.
absolutely awesome. So Cody, we amazing guest. Let me introduce our speaker for today, who has come up with like some great topic for the group here. Let me introduce Doug Bonser. Hey, Doug.
Hey, Karthik. Hey, Cody.
Hey Doug.
Happy New Year.
Happy New Year. All right, Doug. Do you wanna introduce yourself to the group here and tell a little bit more about yourself and what you do and why you are here?
Sure. So my name is Douglas Bonser. I'm going to talk today about the Amazon Document DB with MongoDB compatibility, JDBC driver, and show some demos about that. But I've been with AWS for a year and a day. So it was my 1 year anniversary yesterday.
Happy
Prior to
anniversary, Doug.
Hey, thanks.
Congrats.
Thanks, guys. Prior to that, I worked at Couchbase. It's another document database. So a lot of experience with document databases and JSON and the types of use cases. So yeah, really excited to talk to you today about this driver and show you some of the neat things that you can do with it.
That's awesome. Yeah, when it comes to databases and my interaction with customers, yeah, I mean the database should meet performance, scale, and all that. But also, as customers, mature in terms of their usage of DocumentDB or any database for that matter, I think it's an obvious next step to start seeing the data, start visualizing the data, and start making sense out of the data. Right? Like it's one thing about storing and quick access, but also from a strategic angle, how do you visualize the data? So I think this is a great topic to start off our year with. So I'm super excited to have you with us here. So thanks for making time, Doug.
Yeah, you're welcome.
Cool. So let me see if you can get your presentation going. So hopefully folks can see the presentation here. I'll let you get started. The floor is yours, Doug, and we'll bring in the question from the participant and ourselves, and make sure that we keep this as informative as possible for our audience.
All right, great. Okay, so let's jump right into it here. So the agenda for what I'm going to talk about and show is just a brief overview of what is Amazon Document DB. All right, so if this is your first time joining one of these Insider Hour sessions, I give you a little bit of background about what Amazon Document DB is and a little bit of overview on the architecture. But the primary focus of the session is the rest of the agenda here, and we'll dive into what is the Amazon Document DB JDBC driver, talk about schemas. Right, so this is in my opinion, one of the key things to understand when using the JDBC driver, understand how they are, or how the driver discovers them and how they're used and what you can do with them. Then talk about the setup. We'll look at the setup in the context of a BI tool, a Tableau desktop, and a developer tool called a DB Visualizer. And then last, we'll dive into schema management a bit and show you how you can modify schemas, right, and adjust them to suit your needs and manage those. Okay, so with that, start off again. What is Amazon DocumentDB? So Amazon DocumentDB is fully managed, scalable document database service that supports MongoDB workloads. So want to drill into each of those 3 points a little bit more here. The first being fully managed. So as a fully managed AWS service, right, DocumentDB takes care of a lot of that heavy lifting for you. Things like built-in high availability, being able to deploy a DocumentDB cluster across 3 availability zones for high availability within a region. We have backups are enabled by default. Right? So your data is always backed up. Actually, you can't turn off backups because we want you to leverage those best practices of having your data backed up. And you've got point-in-time restore capabilities, ability to do manual snapshots as well. Your data is highly durable by default. I talked about clusters being deployed across 3 availability zones. Your data is across 3 availability zones as well. And we'll see a little bit more about how we get that high durability when we talk about the architecture. You leverage security best practices baked in by default, things like encryption at rest, encryption at transit. Those are capabilities built into the product. And again, those are enabled by default. So we certainly want you to take advantage of securing your data, securing your access to the database. And then lastly, last 2 rounding it out, automatic patching, right? As a fully managed service, you don't need to worry about the patching of the underlying OS on the instances or the patching of the service. That's all handled by the service, and monitoring and alerting. So you've got capabilities to subscribe to what we call events in the service. Right? So if a node or an instance should happen to fail, or maybe an instance was added, any sort of cluster level or database level events, you can monitor that. And then alerting, right? You can build out custom alerts in CloudWatch, build out CloudWatch dashboards to be able to monitor and see what's going on in your cluster. And then our customer FINRA, what they really like about Amazon DocumentDB, because it's fully managed, they're able to leverage all of these capabilities without any overhead from their engineering teams.
Kind of tying this back to what Karthik was talking about earlier is seeing your data, visualizing your data is huge. That becomes a big portion of it, because when you see the data, you have marketing teams that use that, or you have different areas or different groups that might not have the deep engineering expertise they need to run an entire ecosystem, right? Running database servers, the 3 of us have done it for the heck decades. I'm sure it's not easy. There's a lot to do. And that's the cool thing here about having that fully managed is you have this resilient, this taken care of ecosystem, this document database service running for you that you don't have to really do a whole lot to. We're taking care of the patching, the backups. We have alerts and everything built in. So now if you have a use case to see these metrics like you're going to show us with the JDBC driver, whatever it's connecting to, it just makes that back end so much easier. So I think, that's the big advantage here is you can just get up and running, get started, and all those things that you might not know you need to worry about are handled, which is one of the reasons I love the service.
Right. Great points, Cody. And totally agree. It's so easy to get a cluster set up and start using it. And like you said, you don't even have to think about all of these things that we're taking care of. Okay, so second one I want to talk about, second point here in terms of what Amazon DocumentDB is the scalability. And you'll see this in the architecture slide, but because of the way we've architected this, allows you to scale out your compute. All right, so your instances that are handling the queries and handling the workload. All right, you can scale compute instances out or up or both in a matter of minutes, right? About 8 to 10 minutes. Storage and I/O operations auto scale as well, with storage scaling all the way up to 64 terabytes. All right, so you don't have to worry about, okay, do I have enough disk space on these instances to store my data set? Oh, I don't. Let me go maybe get larger disks or configure a SAN or something like that. You don't have to worry about any of that with Amazon DocumentDB. The service handles that for you, scales that storage automatically. And then lastly, in terms of compute, you can scale your compute instances out to up to 15 replicas, providing millions of read operations per second for the performance there. And then our customer Iron.io, they love this ability to scale like this because they're able to scale their instances in minutes regardless of the data size, whether they've got 10 gigabytes of data all the way up to the maximum of 64 terabytes of data. You can still scale out or up in just a matter of minutes.
Yeah, and that's pretty powerful, right, Doug? So Iron for sure does that, but many customers that I work with, I see them having a predictable scale or peak period where they know, like for example, let's say 10 a.m. to 3 p.m. of and every single day, the user request or the workload is going to receive a lot of requests, and there are going to be a lot of sessions. So basically, more interactions to the database. But anything after that peak time or before, like anything until 9:45 or 3:30, whatever, right? So if it is after that peak period, if there's not going to be much volume, they really don't need to spend money on those larger instances. So I've seen a lot of customers taking advantage of the scalable architecture and spinning up those instances right before that peak. Like if 10 o'clock is your peak, just run a script at 9:45, run those beefy instances, and then at around 3:15 just bring it down, right? So imagine the amount of money it's going to save, because in a 24-hour window, you're just like using it for 4 or 5 hours that you need, and then for the remaining time, the database is still up, but smaller instance. And the key thing here is the predictable time it takes to scale, right? Like it's 8 to 10 minutes, like you said. That's huge, right? No other architecture that at least I'm familiar with will let you do that. So it's really a good option for customers to achieve performance, scalability, and also optimize the cost of workload.
Exactly. So yeah, and not only can they do it on a like a schedule, like you said, but we also have customers doing this based on load. Right, you can monitor the load and scale appropriately, scale up or out or down and in based on the workloads. So
I
really,
remember back in the day, kind of give you a side story here. Just about it's funny how much things have changed, right? Because I remember early in my career, you got the biggest, most powerful server that you could get. Like you went to the Dell.com website or whatever it was, and you just started clicking the drop down area and selecting the largest thing they had. And I remember we had extra budget one year to purchase like basically a sandbox server. And man, I did that. Like I selected the highest, fastest CPUs. I got as much RAM as I could. And I remember the day it showed up and opening it up out of the box and opening the lid. And it was like every single RAM slot was filled. And it was like Pulp Fiction when they opened the suitcase, it's just glowing. I was so happy. I had no idea what I was going to do with it, but it was cool. I had it, right? I'd never seen that before. And just looking back at it now, it's like, man, how wasteful was that? Like, yeah, we had enough RAM to probably run the entire operating system and database server just on RAM, but that just doesn't make sense. Like this optimization, the scaling up and scaling down when you need to, that's the better way, right? Because having that optimization, having that streamline just makes everything about your operations that much better. But I'll always remember that server. I wonder where it is. Maybe I can buy it off eBay.
You should have taken a picture and you should hang it back in your office, Cody.
That's right. Yeah. And the funny thing is, for the amount of money we spent on that back then, I'm sure it's probably like pennies on the dollar now.
Yeah, right. Probably have more. Might have more storage on your iPhone now.
Probably, yeah.
Okay. All right. And then lastly, in terms of what is Amazon DocumentDB, this third topic is it's MongoDB API compatible. So the key is it is compatible, right? So what that means is your applications, drivers, and tools likely can be used with Amazon DocumentDB with little or no change. We do support hundreds of APIs, operators, and stages. And to be perfectly transparent, we don't support every single API, operator, and stage out there. All right, but for the customers that we have, we support 100% of what they need, and we are continually working backward from customers to deliver capabilities that they do need. All right, so if you are looking at Amazon DocumentDB and happen to come across something that's not supported, right, we're always working backwards from your customer needs to get those implemented in DocumentDB. And one of our customers, Freshworks, quote from them is, one of the things they liked about Amazon DocumentDB is their applications didn't require any code changes when they migrated from Mongo to Amazon DocumentDB. So again, that compatibility makes it a lot of times very, very easy to migrate to DocumentDB to take advantage of the other capabilities that we just talked about, like the scaling and the fully managed service. All right, and then just round out this intro to Amazon DocumentDB with a high level of the architecture. So we did architect this from the ground up as a cloud native service, right? So taking advantage of some of the capabilities that you can get from deploying in a cloud, right? So when we look at this, we've separated the compute from the storage, right? I talked about compute instances and storage. Actually, they are separated, right? The implementation is they are separate. So this is not your typical monolithic database architecture where you've got the layer that handles the API calls to the indexing, to the query processor, to the caching, to the storage, all on the same box or same server. All right, these are separated out. So on the top, you see that compute layer, and you've got, in this case, a 3-instance cluster, or you could have a single instance cluster all the way up to a 16-instance cluster. All right, but we're showing a 3-instance cluster here, which is going to give you that high availability, right? 4 nines of availability with a 3-instance cluster here. We've got a primary instance that handles all of the writes or the updates to the data, and then can also handle reads, and replicas handle reads only. So if you have very, very high read rate applications, or it's easy to scale out, again, in a matter of minutes, scale out those replica instances. In terms of the size of the instances, you've got a lot of flexibility from 2 cores all the way up to 96 cores, and 4 gigabytes of RAM all the way up to 768 gigabytes of RAM. And then on the storage layer, again, that is separated from the compute layer. So that's what allows you to scale quickly. All right, you can scale out, add new instances, and all they effectively need to do is just attach to that distributed storage volume. There's no data to move around, as you're adding or removing instances. And now that distributed storage volume is, as you see, spread out across the 3 availability zones. And I forgot to mention the compute instances are spread out across 3 availability zones as well, giving you that high availability. Now, what you see here in the distributed storage volume, you see a lot of these little boxes. We call these segments. All right, so there's segments of data. And ultimately, your document, your data is going to be stored in these segments. And we maintain 6 copies of this across the 3 availability zones, right? So you see 6 green boxes and 6 yellow boxes. All right, so this is what gives you the very high durability of data with Amazon DocumentDB. All right, so with 6 copies across 3 availability zones, all right, even if an availability zone should become unavailable for some reason, all right, you still have full access to your data with the 4 copies and the 2 remaining availability zones. The storage, again, is auto scaling all the way out to 64 terabytes. So as your data set grows, you don't have to worry about managing that and maintaining that. And again, this is a key. I like to emphasize this to my customers whenever I'm talking about document database, right? This is one of the key concepts to understand, is the separation of storage and compute. Lets you do a lot of really interesting things. Like we talked about, scaling out quickly. You can even actually turn off the compute layer entirely. All right, it's great for dev and test clusters, helps you save money. Because the storage is separated, all right, you can shut off the compute layer for up to 7 days at a time. but your data is still there. So say it's like a weekend or a long holiday, you can shut down those dev instances, you come back in, bring them back up, your data is there ready to go. Okay. So now that we've talked about what Amazon DocumentDB is, I want to talk for the rest of the session here about the JDBC driver. So very high level, right? So the JDBC driver is going to allow you to visualize your JSON data that's already in DocumentDB with BI tools like Tableau Desktop, MicroStrategy Developer, and others. The reason I say others are, these are some that I've tried and tested out. But the point is, if the tool supports a JDBC connection, all right, it's very likely to work. The reason I say it's likely to work is, we haven't tested every single tool out there. All right, but the point is, if it does support a JDBC connection, we've got the JDBC driver, and you've got what we're trying to say. Basically, it should work without any issues there. But again, like I said, we haven't tested all of the available tools out there. The second thing it's going to allow you to do is to run SQL queries on that JSON data with developer tools like DB Visualizer, Squirrel Client, dbeaver. So just take a little step back. Another reason why these two things are so important, right? Because DocumentDB is a document database. It's JSON data, JSON documents that you're storing in there. So BI tools you're typically, right, when we think of those, a lot of times we're working with relational databases and tabular data. And certainly when you're running SQL queries, right, you're thinking of running SQL queries against relational databases, data stored in tables and rows and columns. So what this JDBC driver does is really clever. All right, it effectively provides a mapping between a SQL interface into the underlying JSON documents that reside in DocumentDB. And lastly, it's just two words, but this is actually a pretty big point here. The JDBC driver is open source, right? So totally free to use. You're not going to find that with most of the other JDBC drivers out there. So again, there is no charge to use the Amazon DocumentDB JDBC driver. And another interesting point is, this is the first fully supported open source DocumentDB project that we have out there. Right, so just because it's open source, don't feel that, okay, maybe we shouldn't use it because it's open source. No, fully supported and ready to go.
So I want to ask both of you guys a question here for number 2, running SQL queries, right? I'm pretty sure that we all kind of started with SQL, right? With T-SQL statements, select star from table. And on top of that, the three of us have been dealing with document databases for a long time. So we know the syntax, db.collection.find. That's your start from table. How much time, and we'll time box this, how much time in the past week do you think that you've sat there staring at your parentheses and brackets and commas, trying to validate where you screwed one up? Because I don't want to tell you how much time I've spent doing that. So the fact that you can run the SQL, the T-SQL, that's awesome. I love that.
Cody, I heavily rely on the error messages to tell me where I screwed up.
Where are my red squirrely lines?
So I mean, I totally agree. It's certainly, the API query language is it's interesting, I would say, to say the least, right? I mean, it is powerful, but requires that additional learning curve for sure, right? So
absolutely.
Yeah, so SQL queries is certainly pretty powerful. And when I tell customers, you can run SQL on NoSQL databases, I get a weird look. First, that's the instant reaction when they hear it for the first time. But it's so powerful, right? So you get the flexibility, the schema flexibility on one end, and on the other end, you can use a pretty known language. So that makes it a lot easier. And I know with JDBC driver, we're talking about that. That's the content today of the topic. But also, DocumentDB, being a native AWS service, integrates with many other AWS services, Athena being one among them, right? So for folks that are familiar with Athena, you can use Athena, to run SQL queries on S3 and other services. DocumentDB is one among them. So, if you say, hey, all that I need to do is run some SQL queries, I don't want to go through the hassle of setting up a JDBC driver. I'm really not trying to visualize or whatnot. Sure, you can use the JDBC drivers, or you can use the Athena connector as well. So there are like one avenue to the data, or at least query the data in a SQL format. Thanks, Cody. I see that you.
Man, I got to be quick with the links. Got to throw that up there.
Yeah.
We're completely derailing Doug. We're not talking about JDBC, so I'll be quiet. Go ahead.
Right.
No problem. But I mean, that's a great point, Karthik, right? This is not the only avenue for executing SQL queries on data in DocumentDB. So you've got two options there. But again, the focus, on the JDBC driver.
Bring us back. Pull us back in.
Pulling it back in. We're going to talk about schemas. So, okay, schemas. What are you talking about here? So similar to the way the separation of compute and storage, I feel, is key to understanding DocumentDB. Understanding schemas is key to understanding the driver. So how the driver does this, right? So how does the driver allow, take an SQL query and turn that into basically a MongoDB API call under the cover, right? Because that's really what it's doing. So what the driver does is first it's going to generate what we call a schema, and it's effectively an SQL to Amazon DocumentDB mapping. And I'll show you in a little bit what one of these looks like. So after this schema is generated, the driver is then going to use that to provide an SQL interface for querying that JSON data in DocumentDB. Right? So first thing the driver will do, create a schema based on the existing data in the database. Then for queries coming through the JDBC driver, it's going to leverage that schema and effectively map the SQL statement to MongoDB API calls. All right, so in that mapping, all right, so the driver is going to map, in a document database, you've got a database. In a database, you've got multiple collections. In each collection, you'll have certainly multiple documents, and those documents are, a lot of times going to have different formats, right? You'll have different types of documents in a collection. You may have, product documents and customer documents. So the driver is going to create this virtual mapping, or schema, if you will, of mapping collections to tables, documents to rows, and fields in those documents to columns. All right, so now you've got that relational representation of all of the data that's in your DocumentDB database.
And is that just doing the schema discovery like once, just on initial load?
So yeah, so the way it works is the very first time the JDBC driver connects to the Amazon DocumentDB database, it will do that schema. It'll generate the schema. So that's done automatically, and there are some knobs, if you will, on that, right? You can control how many documents to sample to generate the schema, things like that. Now, once it's generated, it is static in the sense that the driver, once it's generated, it's not going to modify that. I'll show you how you can modify that using some command line interface capabilities built into the driver, or you can effectively force the driver to refresh or rebuild the schemas. All right, so let's say you build a schema a month ago and it's working great, but now you've got additional data, or your JSON document schema changed. Right? You've got additional data in there. Well, a month ago, when the driver discovered the schema, those fields weren't there, so it didn't know anything about them. Now there are new fields there, so there are ways that you can tell the driver, hey, go ahead and rebuild the schemas.
No, that's good. Yeah. So like I have someone that I'm working with that they'll do that. They'll do like specials once a month, and they'll add a new field to their document that talks about that new special. So we have the ability with the driver to just say, hey, I know that for January, we're going to do the special. There's going to be a new field, refresh the schema so that we can see the data.
Right. Exactly. Yep. All right, so we'll dive a little bit deeper into these mappings. So the first is the mapping of collections to tables, and it's fairly straightforward. So each collection in the DocumentDB database is going to be mapped to what's called a base table by the JDBC driver, and the names are the same, right? So the collection name is the same as the base table name. So in this case, I was using 2 sample data sets, one called cases collection, cases base table, movies collection, movies base table. All right, so this collection to table mapping, very straightforward. It gets a little more interesting when we talk about mapping fields in the documents to columns. The first is the ID field, right? So every document in DocumentDB has a field named _ID, and this you can think of this as the primary key. All right, so this is a unique value stored in the ID. Now, what the driver is going to do when it's discovering the schema is it's going to map the DocumentDB _ID field to a column with the table name prepended to _ID. All right, so that's a long roundabout way of saying, all right, you do have you're going to have a primary key in the resulting table schema that the driver generated, and the name of that is simply the collection name or the base table name _ID. All right, so you can see that there. Now the rest, in this case, we've got a simple document. This is from our cases data set. They're just all scalar values at the root, if you will, of the document. So pretty simple structure. So in this case, all of these other fields are going to be mapped directly to a corresponding column in the base table. All right, so case type to case type, all the way down to prep flow runtime to prep flow runtime. So pretty straightforward case here. But the nice thing about JSON and document database is you can have very rich structures, very rich document structures with nested objects and arrays of scalars and arrays of objects and so on, right? So you can get very rich schemas in your documents here. So these are handled a little bit differently. So just a quick run through. Now we see, all right, we just learned about the ID field. All right, how that's mapped to a column with the collection name _ID. All right, so this is from our movies collection. All right, so we have a movies base table, and it has all of the scalars at the root of the document. We have year and title. So over here in our corresponding movies table, we see year and title. Now we've got an object, right? We've got an info object. So what the driver does is for any object or array types, it will create what's called a virtual table to store the information in that object or in those arrays. So in this case, we have an info object, and the driver is going to create a movies _info virtual table. Now the name of that table is simply the name of the parent table, which in this case is movies, right? Because info is at basically at the root there, so it's treated as a child of the movies virtual base table. Movies info virtual table as a child of the movies base table, and then we see all of the scalars in movies info. Right, we see release date, we see rating, we see image URL, we see plot, we see rank, we see running time. Also note that we create an ID field. I'll talk a little bit about that on the next slide, actually. But you see these movies _ID keys in each of these virtual tables. And they're also a foreign key back to the base table. But back to what I really want to talk about here with the objects and arrays. So we see the movies info object, all the scalars here in the movies info virtual table. Now we have a directors array, and you see the driver creates a movies info directors virtual table. So going back to this concept of the virtual table name generated by appending the field name to the parent table. All right. So in this case, the field was info. We append it to movies, which is the parent. In info, we have directors. So we append that to movies underscore info underscore directors. And then this is an array of scalars. So the way that is going to look is the driver in this virtual table creates a column called value. All right, and then that's going to card the value of value, in this case would be Ron Howard. And then similarly for genres and actors. Now, if you happen to have an object in your array, that would look a little bit different. You would just have all of the scalar values in that object in your array. You wouldn't have value. This is only used when you have scalars in your array. So yes.
The quick question: how does like level 2 nesting look like here?
So what's like if you would just it would be another if I had let me go back. I'll stay here. So if I had another object in info, is I guess what you're asking. So what you'd have, right? The driver would create, and let's just say that was I don't know, a field called new. I can't think of anything else right now. Okay, so, and that's an object. So what the driver would do would create a virtual table called movies underscore info underscore new. And then you would see, whatever scalars are in there. It would still have the same movies underscore underscore ID acting as a foreign key back to the parent table.
But it will also have something from the info, right? That's the movies underscore info primary key.
So, okay. Yeah, correct. So that ID exists. The name is the same across all of the tables, but for these virtual tables, it's treated as a foreign key back to the base table.
Got it. Okay. So it's just like one more level down into but a separate table altogether.
Right. So as you go, if it's 3 levels, 4 levels, 5 levels, it's just another table with the name of the field appended onto whatever the hierarchy of the parent tables are. The base, the first level, second level, third level.
Understood. Thank you.
Okay. So short way to put it, the parent table, for this relationship, when we're talking about arrays and objects, the parent table can be the base table, which is what we see here. In the case of additional levels of nesting, the parent table would be another virtual table. And then, as I mentioned here, the virtual table primary key name is the same as the parent table primary key name, and it's a foreign key back to the base table.
By the way, if you haven't seen that movie, Rush, about Niki Lauda and James Hunt, Formula One drivers in the 70s, it's awesome. No questions, just to make the comment.
Yeah, and I have to say, I'm a huge motorsports fan, and I have not seen it, so I need to see that.
You a little bit. I'm so disappointed.
All right, so let's take a look at what the setup looks like. I'm going to start with Tableau. Now, I've already downloaded the driver. It's available on our GitHub repository. So there's a jar file. And in the case of Tableau, there is a connector file. And Tableau uses the extension .taco. So I've already put the jar file and the taco file in the appropriate places for Tableau to pick them up. So I'm not going to walk through all of that. But it's pretty straightforward. It's all documented at the GitHub repo. But when I want to actually go ahead and use the connector, I've already got some information filled in here. I am using an SSH tunnel on my laptop to connect to my DocumentDB cluster. Just as a brief aside, DocumentDB is a VPC only service, right? So any clients that are connecting directly to DocumentDB need to be in a VPC, right? It could be the same VPC as DocumentDB cluster, or it could be another VPC. But the point is that client needs to be in an AWS VPC. Since my client, which in this case, the client is the JDBC driver, is actually running on my desktop, I need to leverage an SSH tunnel to be able to connect to the cluster. So I've already got the tunnel configured. We've got that documented as well. If you want to use an SSH tunnel to connect to DocumentDB using the driver, I've already got that set up. So in this case, because I'm using the SSH tunnel, my host name is localhost. I'm using the default port of 27017 on this particular DocumentDB cluster. The database that I want to connect to is named samples. My username, my password. I've used the default of TLS for encryption and transit on the cluster, so I want to make sure that is checked. I do need to check allow invalid host names because I'm using the SSH tunnel. So if you do have this setup where the driver is able to connect directly to DocumentDB from within a VPC, you don't need to check this, but just to make it clear, that's checked because I'm using the SSH tunnel. Now, one of the things that I think is really cool about, or another thing I think is really cool about the driver is it does have an internal SSH tunnel. So if you don't want to go through the setting it up and figuring out what that SSH command looks like and starting it up in a terminal, you can just check this box, all right, and it'll leverage the built-in SSH tunnel. You do still have to provide things. What's the SSH username, the host name that you're SSHing into for the tunnel, and the private key of that host. But again, the point is I'm just using the external SSH tunnel. I'm not enabling replica set mode, again, because of connecting through an SSH tunnel. You're not able to use the replica set, so I'm unchecking that. I do want to enable retrying the reads. I'm using a read preference of primary because I can't use a replica set through the SSH tunnel. All of my reads are going to go to the primary. And these here, this is where we start getting into Cody's question about how is the schema created? How does the JDBC driver discover the schema? So you do have some knobs to adjust here in terms of the scan method. You just want to randomly pick some documents. You want to scan all of the documents, do it by ID forward or ID reverse. I'm just going to go with the default of random, and I'm going to say just scan 1,000 documents. And I'm going to use the default schema name, which is _default. So here's where you start getting into some of the schema management capabilities, where say I want to, in that case where the customer, adds new fields or new data on a monthly basis, right? They could go ahead here. This is one way, or they could do it through the command line, but they could go ahead and provide a new schema name. And now they've got the default schema, and then maybe the January 2022 schema. All right, next month they could go in, provide a new schema name of February 2022, and then they have the February 2022 schema. So you can actually certainly support multiple schemas on the same data set. All right, so I've provided everything I need, and I'm going to go ahead and sign in. It's going to take a few seconds. So I did have the box checked to rebuild the schema, so it did take a few extra seconds there to sample the documents. But once it's connected, you see I have a samples schema. So the schema, the overall schema name, all right, that is going to correspond to the database name. I connected to the samples database. I have the samples schema. And in the sample schema, I've got multiple tables. All right, here is a cases base table that corresponds to a cases collection that I've got in that database. And I can quickly, just drag that table over to the to this area here in Tableau and just get a brief overview, sampling like the first 1,000 rows of the data. And you see I had a movies collection, and we'll look at these in just a minute or two. You can see these virtual tables that got generated. But in the case of cases data, so we're doing some visualizations here. So I have cases data, and I just want to see, okay, what's available to me in this cases data set. So I can see here in this table, this virtual table that got generated, I've got a case type, cases ID, combined key, dates, prep flow, runtime. Basically, all of the fields that were present in my document are here. And Tableau does some neat things, like it will generate some values. It'll generate, there's cases that you'll see in every table. and that's generated by Tableau, right? I didn't actually have this in my documents. Or it's smart enough to recognize that there's some geospatial type of data, all right, and it'll automatically generate latitude and longitude values based on those for, geo sort of visualizations. All right, so you'll see all the fields in your document, plus some additional ones that that Tableau generates for you. But in this case, this is a relatively simple data set. It's just a number of cases per region, per date. So I want to do a basic visualization and just see, okay, based on each country and region, I just want to see the number of cases. All right, so I'm going to use this cases count value that Tableau creates for me. All right, and just very quickly now, I can see and visualize different ways the total number of cases for each region. And just another interesting one I like, especially with this data set, all right, you can change it to this maps type of view. So you've got a world map here, and you can just hover over each of the areas, and it'll tell you the total number of cases for each of these areas, all coming from the JSON documents in DocumentDB. So I do want to show one more. I think this next one's a little bit more interesting. I want to show you on the movies data set, right? Because we've got information across multiple tables here. We have information about genres and directors and actors. And you notice as I'm dragging these tables out in Tableau, Tableau automatically infers these relationships, and you can see it updating down here, and it recognizes that there's a movies __ ID field in both of these. All right, so it's going to use that for the relationship. But let me just build out a visualization here. Now, we've got a lot more data here spread out across a lot of different tables. But one thing that I thought was kind of neat is just looking at, hey, for each of the directors, what is their highest rated, genre of movies. So let me pull out the director, right? And remember, directors was an array of scalars. So the actual director names are going to be in this value, excuse me, field. So we see the different directors, and now I want to look at the genres for these directors. And basically, I just want to see, okay, for a particular director, what is their genre where they have the highest ratings for their movies. Right? So here we have the directors and the genres. Rating information is up here in my movies info. So I'm going to drag that over here. I don't want the sum of the rating. I want the average rating. And I'm going to change this to a tabular. And now I can see across on all of the columns, I've got the directors, the rows, I've got the genres, and the cells here is the average rating. So let's say, hey, I'm looking for a good comedy movie. Who should I look for? Says Stanley Kubrick. Okay, I didn't know he made comedies. So let's try.
Don't take our advice on that one. Do your own research.
Yeah, do your own research. This is a sample data set. Sci-fi comes up with, I think this was in my test, it's Christopher Nolan, which, okay, that seems a little bit more reasonable there. So if I'm in the mood in the mood for a good sci-fi movie, maybe I want to find something by Christopher Nolan. But again, this is just kind of scratching the surface of what you can do in Tableau. I'm far from a Tableau expert, all right, but the point is somebody can come in and within a matter of minutes, just start exploring this data and seeing what they can find out from it, rather than using the MongoDB API or the Mongo shell. I mean, certainly you could do this same thing that way, right? But you don't have to be a developer, right?
All right, Doug, now go to Mongo shell, and as quickly as you just did this here, go do that in Mongo shell. Start. We're timing you.
We need another hour for me to figure that out.
Yeah.
So I did not figure that out ahead of time. All right. So the other one I want to show briefly here is DB Visualizer. So this is a bit different tool. So this is more of a developer tool to run SQL queries. And the first thing that you would do, and again, I've already configured this, is you would configure the driver. And in this case, it's just using the jar file. And the way it works in DB Visualizer, you would go in and create a new driver. I named it Amazon DocumentDB. Browse to the jar file. It'll parse that and create the connection. So that's all done. Create the driver. So the driver configuration is already done, and I'm going to leverage some connections that I've already built. And in this case, it leverages what we call a connection string. We've got a lot of documentation on this in the JDBC driver GitHub repo, but in this case, I'm connecting to DocumentDB on localhost. Again, I'm using the SSH tunnel, connecting to the samples database, and the things that you saw in the Tableau connector configuration dialog, these are part of the connection string. All right, so you see TLS invalid host names true, read preference primary, retry reads true. So in this case, I'm going to go ahead and connect to that.
So, sorry to interrupt. Quick question. Read preference primary, is that because you're going through the SSH tunnel?
Correct.
Can I still use the read preference secondary preferred?
Yes, and if I didn't mention it on the Tableau configuration, I apologize. But yes, the reason I'm using read preference primary is because of the SSH tunnel. Right, and as it is documented, when you are using the SSH tunnel, you can't connect in replica set mode, so you can only read from the primary there.
Got it. Okay.
All right. Okay, so I've connected to this samples database, and I'll expand this. Right, you see the same tables that we saw in Tableau. It's just a little bit different layout. All right, I can click on one of those. I can see the columns. I can see the data. Again, this will just return like a sample of the first 1,000 documents. Again, being a developer tool, it's more around executing SQL queries from the tool. So just to show you briefly a couple of queries. So in this case, using this cases data set, I'm just selecting the country and the total cases from the cases table, grouping them by country and ordering them by total cases. So it's basically that query that you saw, or that visualization that we saw in Tableau, just executing it here as an SQL query. And after a few seconds, right, you see it here in a tabular format with the data. All right. The other one I just wanted to show is on the movies collection and the associated tables. So basically, I'm just querying, okay, show me all of the movies that Robert De Niro was in, ordered by rating, highest to lowest, right? But again, because of the nature of the document with the nested objects and the arrays, we've got these virtual tables that were created, right? But no problem, right? You can simply join across these tables, right? So I'm joining movies to movies info actors and to movies info, right? Because actors is where the actor names are, info is where the rating is. Movies is where the title is. So in this case, I execute that, and I can see that, according to this data set, the highest rated movie that Robert De Niro was in was The Godfather Part 2. Another movie I've not seen. Apparently, I don't see many movies. Okay.
Oh, Doug, geez, the hits just keep coming.
Yes, they do. All right. So no, we've got just a few minutes left here. So the prerequisites, just a recap, is you need an Amazon DocumentDB cluster. You need the driver files downloaded from the GitHub repo, SSH tunnel if you're connecting from outside the VPC, which I was. And in this case, I was using the external option where I'm using port forwarding on my machine, or you could use the SSH tunnel options built into the driver. And lastly, a JRE or a JDK version 8 plus, if you're managing the schema using the JDBC driver command line interface, which I'll show you here in just a minute. Now, every BI tool or developer tool are going to have their own prerequisites, but at a minimum, just to get the driver set up, you need a cluster, you need the driver files, and if you're running it outside of the VPC, you need the SSH tunnel. All right, so let's in the time we have left here, dig into schemas a little bit. So I talked about schemas, right, and how they're generated, how the driver generates them, and we saw effectively through the demos there how you use them, how they're used by the different tools. Now the schema information is generated by the driver, but it's pretty clever. We actually store that schema information back in the DocumentDB database itself. All right, so for the each of the collections, for the database that I connected to, in this case, it was the samples database. If I were to look at that in Mongo Shell, I would see an _SQL schemas and an _SQL table schemas collection in there. So we store all the data in those two collections in the DocumentDB database. So that implies that you've got to have some permissions on the user, that the user credentials that you're providing when you connect with the JDBC driver. So if that user has read-write permissions on the database, that user is going to have full access to schema information. Certainly they can read it, and when the driver creates that schema information, the driver is now going to be able to save that in DocumentDB. If the user that you're using to connect only has read permissions, if the schemas exist, no problem. The driver is going to be able to read them. If they don't exist, right, maybe this is the first time you're connecting, the driver is going to still build those schemas, but it's just going to only hold it in memory, all right, for basically as long as you're using the application connecting through the driver, all right, because that user doesn't have write permission on the database. We can't persist that schema information. So the user that you're using to connect needs at least read privilege, ideally read and write, to be able to save the schema information.
But to be clear, our recommendation here is give that user read write. We don't want it to be ephemeral.
Correct.
Gotcha.
All right, so I'm going to show you using the JDBC driver CLI to manage the schema. Already previously mentioned this option in the Tableau connector. All right, there is a checkbox there. If you didn't notice it, here's a screenshot. All right, you can check that when you go to reconnect. That's if you need to update the schema when you're using something like DB Visualizer or another tool. I showed you that connection string. There's a refresh schema connection string parameter that you could add if you need to do that. And the last, I would say, probably don't want to do this if you don't have to. It may be good for like a dev cluster, right? But you could always just go in via Mongo Shell and drop those collections that the driver generates. And the next time it connects, it's going to recreate those. So again, use the CLI or use the options in the connection string or the connector settings. These are kind of a last resort or a good maybe for development environments. All right, so in this demo, I'm going to quickly show you, listing the schema on a collection, exporting it, making some changes, importing it. The documentation at the GitHub repo has, full details on all of the different options available to you. But let's see what this looks like. So first, I'm going to go ahead and connect to a different database here got called Schema Management to go ahead and build that initial schema. And I want to show you some of the options that you have on the command line. So the first thing is to just go ahead and let's see what schemas exist on a particular database. So I need to provide my credentials. So I'm using the options in the JDBC driver jar file, and I'm using the list schema option. I'm telling it connect to localhost. So there's my SSH tunnel configured to connect to my samples database and connect to this database called Schema Management. And I see that right now I just have a default schema, as we would expect, right? Because I just used the driver to connect to it, and there's one version of it. So I want to see, let's see what tables, right? What tables were discovered by the driver. So there's this list tables option. So I'm going to use that. And I see,
Time check. We have like about 10 seconds. Sorry.
okay. All right. So, and I can see here that there's an orders table. The next thing that I wanted to show is, here is the schema as it exists. Right, I can see the name of the collection. I can see the SQL names, SQL names. I can change these, right? If I want the table name to be like customer orders, I can change it. If I want first name to really be customer first name, I could do that. I could remove things like type that I don't want to have present there in my schema. So you've got a lot of flexibility. You can change it, upload it, and now you're good to go. All right. So in closing, just in terms of next steps, take a look at these links. The first one is going to help you set up a DocumentDB database cluster. So you can start working with that. The second link is going to direct you to the GitHub repo where you can download the driver, read all the documentation. The third one is an article about getting started with it, walks you through setting it up and configuring the driver, configuring the tools. And then lastly, a link to some more hands-on workshops to get more familiar with DocumentDB. So with that, apologize for running over, but thank you all for your time, and thank you, Karthik and Cody, for inviting me to the show here today.
Go watch Rush and Godfather 2. More importantly, Godfather 2.
Okay, so when you can't reach me on Slack today, that's what I'm doing.
Totally good excuse. That's all right.
Thank you, guys. That was a fantastic session. Thank you so much. And folks, for those who have missed it, I will share the recording on my LinkedIn and through the analytics channel as well. Thank you, everybody. Stay safe. Take care. Bye-bye.
Thanks, everyone.
Bye.